Everyone says traveling at the speed of light is impossible. Ah, and they're right. But that's not the interesting part. The interesting part is what happens to you as you try. Because the universe doesn't just say no, it says no in the strangest, most beautiful, most terrifying way imaginable. And to understand that, you don't need a physics degree. You just need to pay attention to what you already know. Let me show you. Right now, you are sitting still, honey. Or at least you think you are. But you're not. You are on a rock spinning at about 1,000 miles an hour. That rock is orbiting a star at 67,000 miles an hour. That star is whipping around a galaxy at nearly 500,000 miles an hour. And you feel none of it. Not one bit. You don't feel the wind. Oh, you don't feel a pull. You don't feel anything at all. Why? Because speed, constant speed, does not register. Your body has no speedometer. It has no way to know how fast it's going in a straight, steady line. This is not a flaw. This is a feature. Galileo figured this out centuries ago. If you're on a perfectly smooth train, no windows, no bumps, you could be going 10 miles an hour or 10,000. You wouldn't know the difference. You could pour a cup of coffee, toss a ball in the air, do a push-up. Everything behaves normally. One day, nights chill, I'm sorry, ways. So speed itself is not the enemy. That's important. Hold on to that. Now let's talk about what is the enemy. Acceleration. Upness. The change in speed. Our start and the change. The getting up to speed part. That's where things get uncomfortable. And potentially lethal. Think about it this way. You're in a car. You're cruising on the highway at 70. You feel fine. Now someone rear-ends you and you go from 0 to 70 in half a second. That kills you. Same speed. Totally different experience. I do nicely outside. In my basis, I'm once. The difference is not the speed. It's how fast you got there. Your body is basically a bag of fluid held together by tissue and bone. When you accelerate, everything inside you wants to stay put. Your blood wants to pool. Your organs want to shift. Your brain wants to slosh around inside your skull. We measure this force in Gs. Men, 1 G is what you feel right now. Just sitting here. Earth pulling you down. You're built for 1 G. You've been living in it your entire life. Fighter pilots, the best trained humans on the planet for this kind of thing, can handle about 9 Gs, but only for a few seconds. No, and only with special suits that squeeze their legs to keep blood from draining out of their heads. Without those suits, without that training, most people start losing consciousness around 4 to 6 G. Your vision narrows, goes grey. Then, black. Your brain is starving for oxygen because your heart can't push blood upward against that force. Now, the speed of light is 299,792,458 meters per second. Let's round it. About 186,000 miles per second. Not a second. Per second. You could wrap around the Earth more than 7 times in the time it took you to blink. If you wanted to go from standing still to that speed in, say, 10 seconds like a dramatic movie launch, you would experience over 6,000 G. 6,000 times the force of gravity. You would not just pass out. You would be flattened. Liquefied. You'd be less a person and more a stain on the back wall of whatever vessel you were in. So forget the dramatic launch. Let's be smart about this. What if you accelerated gently? What if you accelerated at just 1 G? The same pull you feel from Earth right now. Comfortable. familiar. Dorsaya, nixtaisutse, defwa, like standing in a room. Mustard counting, outstanding in a room. Your bones can handle it. Your blood can handle it. Your brain stays happy. At 1 g of constant acceleration, it would take you about 11 months to reach the speed of light. Almost a full year of steady, comfortable acceleration. At 2 gs, you could cut that roughly in half, down to about 5 or 6 months. At 3 gs, even faster. But now we're getting into territory where we don't fully know what a year of sustained, elevated g-force would do to a human body. We know a few seconds is fine. Noon. A few minutes probably. But months? We've never tested that. No one has ever lived at 3 gs for a year. We don't know what happens to your bones, your heart, your eyes, your joints, under that kind of prolonged stress. So even the gentle approach has limits. But let's say you make it. Let's say you solve the engineering. You have a ship, you have fuel, you have time. You accelerate at 1 g for 11 months. What happens? And here is where things get strange. Because the universe doesn't just let you accelerate to light speed. It pushes back. Not with a wall. Not with a force field. Not with a force field. With something much weirder. With math. With the actual structure, reality itself. Let's walk through it. At low speeds, say 10% the speed of light, things are mostly normal. You look out the window. Stars look like stars. Maybe a little shift in color, but nothing dramatic. Your body feels fine. Time feels normal. You weigh what you always weigh. Nothing to worry about. At 50%, the speed of light, things start to change. Not catastrophically, but noticeably. Right for macro. The stars in front of you begin to bunch together. They drift toward the center of your view, as if the sky ahead is being squeezed. Behind you, stars spread apart and start to dim. Colors shift. Stars ahead of you look bluer than they should. Stars behind you look redder. This is the same Doppler effect you hear when an ambulance passes you, and the siren drops in pitch. Except instead of sound waves stretching and compressing, it's light waves. You are running into light in front of you, compressing it, making it bluer, more energetic. Light behind you is stretching out, losing energy, turning red. Think of it like running through rain. For instance, if you stand still, rain hits you evenly. But if you run forward, more rain hits your front. Your chest gets soaked. Your back stays dry. At near light speed, you are running through a rain of photons. More of them smash into your face. Fewer reach your back. The universe ahead gets brighter. The universe behind goes dark. Stop right there. This is still just an optical effect. If you turned around and headed back, everything would reverse. The colors would flip. The stars would rearrange. It's a trick of perspective. Like looking at a straw in a glass of water and thinking it's bent. It's not really bent. Light is just doing something funny on the way to your eye. But keep going. Push past 50%. Not get to 80. Then 90. Home stays. Then 95. And now the tricks stop being tricks. Nay. At 90%, the speed of light, time itself begins to walk, not in a way you feel. That's the sneaky part. Is it days, is now, already it. From your perspective, inside your ship, everything is normal. Your heart beats at the same rate. Your clock ticks every second. You blink, you breathe. You think at the same speed you always have. Nothing feels different. But if you could look back at Earth, if you had some magical telescope pointed at a clock on the wall of your living room back home, you would see something unsettling. That clock is running fast. Not because it changed. Because you changed. Or more precisely, because the relationship between your time and Earth's time has changed. At 90% light speed, time for you is running at roughly half the rate of time on Earth. For every 10 minutes you experience, 20 minutes pass back home. For every month you live, 2 months go by on Earth. And this is not an illusion. This is not a trick of light or perception. This is real. Physically, measurably, experimentally confirmed real. We've tested this. Not with spaceships. With clocks. With clocks. Atomic clocks, the most precise timekeeping devices humans have ever built. Put one on an airplane, fly it around the world, compare it to one that stayed on the ground. They disagree by tiny, tiny amounts, because airplanes are slow compared to light. But the disagreement is there, exactly as Einstein predicted. And your GPS satellite system? It has to account for this every single day. If it didn't correct for the time dilation caused by the satellite speed, your phone's map would drift by miles. So, time dilation is not philosophy. Oh, it's engineering. Think about that for a moment. Now, push further. 99% the speed of light. Here, time dilation becomes extreme. For every minute you experience, roughly 7 minutes pass on Earth. A year for you is 7 years back home. You leave Earth at age 31. You travel for what feels like 5 years. You come back. You are 35. But everyone you knew is 65. Your kids are older than you. Your friends are gone. The world has moved on by 35 years while you aged 5. This is the twin paradox. It's not really a paradox. It's just deeply uncomfortable. Both experiences are real. Both timelines are valid. You really did age 5 years. They really did age 35. Nobody is wrong. Nobody is lying. Time simply passed at different rates because you were moving and they were not. And it gets stranger. At that speed, space itself contracts. Not metaphorically, not visually, physically. The distance between you and your destination actually shrinks. A journey to a star 20 light years away doesn't take 20 years from your perspective. It takes much less, because for you, the distance is shorter. The universe in front of you is compressed, squeezed, like an accordion being pushed together. So from the outside, from Earth, people watching, you would say you travel 20 light years in just over 20 years. Makes sense. Speed times time equals distance. But from your perspective, you traveled a much shorter distance in much less time. Both are true. Neither is an illusion. Space and time are not fixed. They are flexible. They stretch and compress depending on how fast you're moving. This is special relativity. And it is not a theory in the way people use that word casually, like a guess or a hunch. It is one of the most tested, confirmed, validated frameworks in all of science. Now, here is the wall. You are at 99% the speed of light. You want to go faster. You pour on more fuel, more energy, more thrust. And you do go faster. 99.9% Einstein something to you I necessarily actually 99.999 each decimal place harder than the last. Why? Why? Because as you approach the speed of light, your energy requirements don't just increase. They skyrocket vertically. Toward infinity. The relationship between your speed and the energy needed to increase it is not a straight line. It's a curve that bends upward like a wall. The closer you get to light speed, the more energy you need for each tiny increment of additional speed. And at light speed itself, the energy required is infinite. Not very large. Not astronomical. Infinite. Nonce. As in, all the energy in the observable universe would not be enough. As in, it cannot be done. Period. Stein. This is what Einstein showed. This is what the equation says. Energy equals mass times the speed of light squared. And embedded in that equation is a consequence that no one expected. As an object with mass moves faster, its effective mass increases. At everyday speeds, the increase is negligible. At 10% light speed, your mass goes up by about 0.5%. Barely noticeable. But at 90%, your mass roughly doubles. At 99%, it increases about 7-fold. And as you approach 100%, the mass climbs toward infinity. You become, in a sense, the heaviest thing in the universe. And you need infinite energy to push an infinitely heavy thing. The universe has a speed limit, and it enforces it not with the sign on the road, but with the actual structure of matter and energy. The speed of light is not just fast. It is the boundary condition of the cosmos. It is the speed at which massless things, and only massless things, can travel. Photons. Gravitational waves. Things with no rest mass at all. They don't accelerate to light speed. They are born at light speed. They have no choice. For a photon, there is no slower. There is only the speed of light. And for you, there is no that fast. There is only almost. And here is something that will keep you up tonight. No matter how fast you go, light still moves away from you at the same speed. This is the most counterintuitive thing in all of physics. If you're on a highway going 60 and someone passes you going 90, they pull away from you at 30 miles an hour relativity. Makes sense. Basic math. But light doesn't work that way. If you are going 50% the speed of light, and a photon passes you, that photon is not moving away at 50% of light speed. It is moving away from you at 100% of light speed. The full speed of light. As if you were standing still. If you speed up to 90% light speed, that photon is still leaving you behind at the full speed of light. You cannot close the gap. You cannot catch up. No matter how fast you go, light is always outrunning you by the same amount. How? How is that possible? Because time and space adjust. They bend. They flex. They conspire to keep the speed of light constant for every observer, no matter how fast that observer is moving. Your clock slows down. Your rulers shrink. The universe rearranges itself, quietly, seamlessly, to make sure that one number never changes. 299,792,458 meters per second. Always. For everyone. Everywhere. That's not a speed. That's a law. So what would you see if you kept pushing closer and closer? At 99.99%, the universe in front of you collapses into a tiny, brilliant point. Almost all the light in the cosmos, from every star, every galaxy, every corner of the sky, gets funneled into a blazing white dot dead ahead. The Doppler shift has pushed starlight beyond blue, beyond ultraviolet, into wavelengths your eyes can't even see. X-rays, dotting, million X-rays, gamma rays. You are being bathed in radiation that would cook you alive. Behind you, nothing. Total darkness. No light can catch you from behind. It's all in front. The stars don't look like stars anymore. They look like a single flashlight pointed at your face, and the universe behind you has simply vanished. Not destroyed. Not gone. Just invisible. Its light can't reach you. Your field of vision is a tunnel, a shrinking circle of searing light ahead, and an expanding void of black behind. The edges of reality are being compressed into a pinprick. And time. Time for the rest of the universe has, from your perspective, sped up beyond comprehension. Civilizations rise and fall in the blink of your eye. Stars burn through their fuel in what feels like minutes. The universe ages while you barely breathe. Where does seconds like dichotomized? But you never get there. You never reach the speed of light. You can't. The speed of light is not a destination for anything with mass. It is an asymptote, a line you approach forever but never touch, like trying to reach the horizon by walking. Every step brings you closer, and the horizon is always the same distance away. Now, let me tell you why this matters to you. Right now, sitting where you are. This isn't abstract. This isn't about hypothetical spaceships and imaginary journeys. The speed of light is why you exist. The relationship between energy and mass, encoded in that speed, is why the sun shines. Deep in the sun's core, hydrogen atoms are being crushed together, fused into helium, and a tiny fraction of their mass is converted into energy according to that equation. E equals mc squared. The c in that equation is the speed of light. And because that number is enormous, even a tiny amount of mass produces a staggering amount of energy. That's what powers the star that warms your skin. The speed of light is also woven into every atom of your body. The electromagnetic forces that hold your molecules together, that keep your feet on the floor, that let your neurons fire, they all propagate at the speed of light. When you touch a table, the reason your hand doesn't pass through it is because electromagnetic fields, traveling at the speed of light, push back. The speed of light is the clock speed of reality. It sets the pace at which causes lead to effects. It determines how fast information can travel from one place to another. It is the reason there is a here and a there. Without it, without that finite speed, everything would happen everywhere all at once. There would be no sequence, no before and after, no story, no you. So the fact that you can't travel at the speed of light is not a limitation. It's the architecture. It's the scaffolding on which the entire universe is built. Every force, every particle, every interaction is shaped by that number. It is not something the universe imposes from the outside. It is something the universe is made of. And here is the honest ending. We don't fully know why the speed of light is what it is. We know its value. We know its consequences. We can calculate what it does to time, to space to mass to energy. We have confirmed it to more decimal places than almost any other constant in nature. And it is written into the definition of the meter itself. 1 meter is literally defined as the distance light travels in 1/299,792.458 of a second. But why that number? Why not faster? Why not slower? Why does the universe have a speed limit at all? We don't know. We can describe the rule. The rule. We can use it. We can build technologies that depend on it. We can predict its effects with astonishing precision. But we cannot explain it. I didn't explain it. Not at the deepest level. It's thing in the soul. The speed of light sits at the foundation of physics, and beneath that foundation, there is still mystery. We have taken particles, tiny subatomic particles, and accelerated them to 99.99999% the speed of light. In the Large Hadron Collider, protons circle a 17-mile tunnel at speeds so close to the cosmic speed limit that the difference is almost meaningless. And even there, even at those unimaginable speeds, they never reach it. They get closer. And closer. And chip. And the energy required for each tiny fraction of a percent more goes up. And up. Up. And the speed of light stays where it is. Untouched. Unreachable. Constant. The universe has a boundary. Not in space. In speed. And everything you are, everything you see, everything you will ever know, exists on this side of it. That's what happens to your body at the speed of light. No, I don't. Nothing. Because you never get there. But the trying, the approaching, the getting close, that changes everything. Time bends. Space shrinks. And neurons. Mass swells. Light warps. Light in a star mention. Light warps. Reality itself rearranges around you. Not to stop you, but to keep its deepest rule intact. The speed of light is not a wall. It's a mirror. The closer you get, the more the universe shows you what it's really made of. That's the speed of light. What out? That's